Okay, today we're going to talk about homeostatic systems and drugs. And I'm also going to hit chapter 5 too. By now, you've probably figured out that these videos are very short, about 20 minutes, sometimes 40, but they cover the highlights of the chapters. You need to make sure you read the chapters. I highly recommend that you do the workbook sheets that I've given you. Those are usually paid for. But I'm pushing them onto the modules for free. So make sure you complete those. And then when you listen to this module, know that I'm also going to be hitting the discussion question and also the assignment. So let's get started. So homeostasis. You probably know this term from biology. It's the idea that your body is constantly leveling itself, trying to self-regulate. It uses the nervous system, which is like electrical and chemical, to send messages, and the endocrine system, which uses hormones, chemicals, to send messages to your glands to release hormones. There's constantly equilibrium, trying to keep everything equal, trying to keep you out of fight or flight mode, and try to keep you balanced. So what happens is that we're just kind of a quick review of the nervous system. You're probably familiar with this from biology, but I want to go over some key terms. There's basically a specialized nerve cell composed of neurons and glia. And neurons are responsible for conducting the homeostatic functions of the brain. And I'm going to have a picture here briefly. They are impulses. And then from their electrical impulses, they have neurotransmitters, which are chemicals that are released. And then they're receptors. Now, when you watch the reward circuit videos for NIH, you will see these chemical messages going across the synapses. So let's go over this. I'm going to slow down here. This is the process of sending a message by neurons. It starts off well, actually, it's a circuit. And let's go from A to B to C to D. There's an electrical impulse that travels across your neurons. This impulse then hits the synapses and it sends a message. It says, release a neurotransmitter. Then from there, and if you see this, it'll do a signal. It will then go, and this D and C are expanded here. It releases this, and then a neurotransmitter is released across the synapses. The synapses are between D and C here. And then all the NIH videos and everything you'll see that these neurotransmitters are released and send the signal. Neurotransmitters are messengers. And you will see how drugs actually block either the uptake of this neurotransmitter or inhibit it from even being released. So this is a brief overview here. So neurons and neurotransmitters. Each of these terminologies, neurons can send discrete excitatory or inhibitory messages. So either excites or it inhibits to the targeted cells. And their neurons are distinguished by the type of neurotransmitter they release. And so one of the biggest neurotransmitters, and this is the chemical message that goes across the synapses, is dopamine. Dopamine controls as a neurotransmitter that is about reward, and it activates the pleasure center. And this is the one that is powerful. It basically has this feeling, when people feel it, they feel like they're about to anticipate a reward. And this is one of the most powerful neurotransmitters in the body. I want you to know the different neurotransmitters. So this is really important. I'm going to ask you to describe it in one of the assignments, and then you're going to need to know it throughout the whole entire course. So these are the neurotransmitters that are most impacted by drugs. Now, these are not all the neurotransmitters, but you're going to hear these are the neurotransmitters, the chemical messengers that are blocked or stimulated by drugs. So I want you to know these. Dopamine, what is the effect? It has an inhibitory and an excitatory effect. So we either can get you anticipating an reward or it gets you excited. This is the chemical messenger. And so these are the central nervous system changes. You can actually feel euphoria, like excitement and happiness. Agitation, you might feel nervous. And even when you get so much dopamine in your system, you can feel paranoid. The drugs of abuse, these are the ones that can come in and either inhibit or excite it and make dopamine release more into your system or block the uptake of dopamine so you have a lot of dopamine in your system, or amphetamines, meth, cocaine, bath salt. You'll hear about GABA. GABA is inhibitory. And so these are the drugs that either inhibit GABA or stimulate GABA, that neurotransmitter being released into your system. Serotonin. And you'll see that LSD is the drug that really pushes the serotonin. Tobacco, nicotine, probably one of the most addictive drugs, pushes acetylcholine. Narcotics block the uptake and push endorphins. So these are the different types of neurotransmitters that are impacted by drug abuse. And then we have different ones like marijuana and spice. So what I want you to do is I want you to go to your book and read the section. It's really important because this PowerPoint's not going to go into each one of these neurotransmitters, and wrap your head around how these chemical messengers are either inhibited or blocked by drug use. But first, you really need to know about these neurotransmitters. These are chemical messengers that are in your body. And what drugs do, they're psychoactive agents that come in and actually mess up the signals. So your body can get to the point where, why even release one of these neurotransmitters, right? Why even release it? Because someone is taking cocaine or meth, and it's actually inhibiting or blocking the uptake of dopamine or GABA or serotonin, and your body will stop producing it or become dependent on this drug that's being introduced to the system. So why even produce the serotonin? Your body starts to become dependent, either psychologically or physically, on one of these drugs, and we're going to have the neurotransmitter release. So get your head wrapped around the different neurotransmitters. And so dendrites are the receiving region of these neurotransmitters. And you can see that dendrites are the little octopus arms. And synapses are where these neurotransmitters travel. And the synaptic cleft is the distance between those gaps. So if you look at this, you can see that how these neurotransmitters travel across these synaptic clefts. These were when the drugs are introduced into the system and either blocked or inhibit. So I want you to understand that that there are different ways that how drugs can get in the way with these synapses, either exciting a synapse or inhibiting the uptake of a synapse. Okay, so you need to understand that these synapses are the gaps between those two areas. And drugs can actually inhibit the uptake. So you can see how a drug can come in and either block it or inhibit it. There's basically two different types of drug receptors: an antagonist, where it actually activates a receptor, or an agonist, I meant to say, where it actually activates it. So you think an agonist is activating it, and an antagonist is actually blocking and preventing the uptake of a neurotransmitter. So there's an agonist where it actually comes in and it activates the neurotransmitter, or antagonists where it blocks it. So you'll see that when you look at the NIH videos on the reward center, you'll see that cocaine will act as an antagonist, actually block the uptake. So neurotransmitters, these are the ones that are frequently altered by drug abuse. And I mentioned them before, and I want you to know them. The different ones: acetylcholine, catecholamines, serotonin, GABA, endorphins, and anandamide. So I want you to know those different ones, and they each have a different chemical here. So what happens is your body is chemical. Think about it. Those neurotransmitters that are going across your body are chemical. And when a drug comes in, it actually starts to alter the chemistry of your body. So these are the different chemicals that are out there. And they start to play with these different chemicals. And you can see how, if you look at these different chemicals here, for each one of these neurotransmitters, again, are chemical messengers. Hormones are chemical messengers. And we're going to talk about the difference in a minute. But you can see how they look very, very similar. And so a drug coming in can actually sometimes mimic a neurotransmitter and trick your body. So these are neurotransmitters that are already in your body, that are already in there working across your system. And when a drug comes in, it actually can chemically look like a neurotransmitter. So I want you to make sure that you know the central nervous system, right? The central nervous system is going straight down your body. And then you have something called the peripheral nervous system, which is going out to all the different areas. When a drug comes in, it starts to alter and play with your central nervous system and your peripheral nervous system. So central nervous system includes everything that is in your brain and spinal cord. And so you can see that when I talk about drugs and we're talking about the reward system, it's often playing with the limbic system, is where your reward center is located. And one of the ones that the drugs play with the most is dopamine. So it starts to play with the central nervous system, and it starts to inhibit the processes in the central nervous system. And it starts to actually go in there, and you'll see that sometimes drugs will actually either slow down the central nervous system and sometimes shut it down completely. So when we talk about central nervous system and drugs that depress it, it will actually start to depress the vomit center, the respiratory center, and sometimes people will actually stop breathing because drugs will come in and inhibit the ability for the central nervous system to actually work. So go ahead and take this little game if you want to, and see if you can anticipate the drug and how it inhibits the system. And I'm going to go ahead and put that in there so you can play with this. So the peripheral nervous system actually can be inhibited by drugs too, but by both input and the output. And so just a quick review, they'll start to have things where you'll have drugs that will inhibit the norepinephrine and the acetylcholine. They'll actually start to come in there and act in an antagonistic fashion. So you could see all the different areas that your central nervous system is in charge of. And think about this. When a drug comes in, it starts to inhibit at the neurotransmitter level. And think about how it blocks the system, and how like the heart can be affected, the lungs can be affected, even the stomach can be affected. The next thing that I want to wrap your head around is the endocrine system. And you might be like, well, how is the endocrine system different than the central nervous system? How I like to think of it is that the central nervous system is electrical in nature and chemical. Endocrine system is purely chemical with hormones. It's purely hormones. So the hormones are released and it travels through the glands and it goes through the blood. Okay, so when you think of endocrine system, think of blood. When you think of central nervous system, think of nerves and neurons and electrical messages that then release chemical messages. But endocrine is purely blood and chemical hormones, okay? Hormones are released in the endocrine system. And drugs affect both. It can affect the endocrine and the nervous system. So let's go into the endocrine system. They're hormones for the endocrine system. They affect tissues. They affect organs, okay? So when I say hormone, think chemical into your glands, into your organs, okay? So like a gland is a liver, ovaries, testes. Think of along those areas. So here are the different glands: pituitary, thyroid, pancreas, adrenal gland. And what happens is these are the hormones. Do you see some of those hormones? Like Oxycontin. Do you see that one? That's a drug, right? That actually can inhibit and affect the hormones. Insulin, steroids. Do you ever hear of people taking steroids and then they get aggressive? Remember, hormones are chemicals and they travel through the blood and they affect the glands, but they can affect your body. So think of two ways that your body sends messages, one through the central nervous system and the other through the endocrine system. And the endocrine system is blood and glands, okay? So these are some of the hormones, androgens, and then anabolic steroids. You might hear someone abusing anabolic steroids. And see, anabolic steroids is a hormone that is chemical. So therefore, think of it, if you're thinking, wow, hormones or chemicals are like drugs. Yes, hormones are chemicals, but they travel through your blood. And they're controlled as Schedule 3 substances. So anabolic steroids are hormones that people can take, and they are a drug, okay? Hormones are chemicals. Drugs are chemicals. So if you start to see a gray area over there and it's crossing over, yes, it is. That's definitely a gray area. Hormones and drugs are very similar. And so what I'm going to do now is I'm going to point out now to the different areas for your questions. And I want to make sure that you see this. And we get to the share here. And I want to pull out to the modules for this week. And so what you need to do is the video is being posted here, but watch these NIH brain responses. I can't tell you how important it is. That's why you can see how the nervous system can be hijacked by drugs. So that's your nervous system. But at the same time, your endocrine system can be hijacked by someone taking hormones and messing up how the chemicals are being released in your endocrine system. So watch the NIH drug videos. They're awesome. Take the brain game so you can wrap around how neurotransmitters work. Do these 2 worksheets. I can't tell you how great these worksheets are, because if you do these 2 worksheets, do 4 and 5, you're going to get it. Then I want you to dive into the discussion question about how addiction can begin. I want you to really wrap your head around the fact that tolerance is a big thing. Oh, and I want to make sure I highlight that before we get off of that chapter 5. I want to move right to that because I want you to see in chapter 5 the addiction. And then neurotransmitters and drugs. I'm going to actually ask you to pick a neurotransmitter and talk about how drugs can hijack a neurotransmitter. So before I get off of this, I want to go to this slide right here. So this talks about how addiction can happen. When a drug is first used, someone can have a positive experience or an unpleasant experience. If they have an unpleasant experience, they often stop. If they have a positive experience, they start to do frequent use. The brain then starts to actually stop producing these neurotransmitters, and it starts to change chemically. They then develop tolerance. Often they develop tolerance, and this is where physical addiction becomes. They have to increase their use of the drug to even feel anything. So often you'll hear people who become addicted to heroin say they never get that high that they first got, and they have to take more and more of the drug to get that high. And then they never get that high again. They have to take the drug to even function. Okay, so that's called tolerance. Dependence then becomes either physical or psychological. And physical is that if they stop taking it, they could actually die. So alcohol has a high dependence, physical dependence. People can go into serious DTs, delirium, tremors, where they can start to hallucinate. Heroin has a huge physical dependence. So we're going to talk about dependency, but the idea is that some drugs, people can become immediately physically, and right from the first use, like for example, meth. People become physically addicted from the first use. And then psychological dependence, they start to get emotional discomfort. So take a look at that. Okay? And I want you to make sure you go over this. So here are the different uses. You need to understand that people start to get, and I'm going back through this here, they start to get effects and unintended responses from this. They can have side effects that either get them to have a physical response that they like or don't like. And these are all the things that start to get impacted by this. Do you see that? So I want you to go through this PowerPoint, and I want you to see that even like with ibuprofen, some people have to take just a little bit and they get the impact of the drug. Or they have to take a lot to feel the drug. And know that if you start to go over 800 milligrams for ibuprofen in one day, you're going to have a toxic effect. So it's the same thing for drugs. There's a margin of safety. There's potency versus toxicity. And I'm going to come back to this, and I want to make sure that you understand that a drug, you have to sometimes increase the use to feel the potency of it. And at one point, it becomes toxic. So let's go back to this slide right here. People can actually get to the point where they increase the drug so much that it becomes toxic and they die. So go through this PowerPoint, wrap your head around it, and read chapter 5 and begin to understand how drugs can inhibit the body and how someone can become physically addicted from this. They can become physically addicted and psychologically addicted. And they can start to get cross tolerance where they actually take another drug and it impacts them. They can have a rebound effect where if they don't take it, they have an effect. So become familiar with each one of these terms. And I want to make sure that we define addiction. Addiction is sometimes confusing. And so I want to make sure that people understand that addiction is when someone becomes physically and compulsively addicted to a drug. They need it in order to function. But here are some of the factors for addiction. Some of it's hereditary. You could be genetically actually set up for addiction and become 40 to 60% more vulnerable because synapses and everything are genetically passed down. There's some people can actually have a drug craving. Other things is that people can actually have a negative or positive effect to a drug. So someone can actually take it for the first time and never feel the effects of the drug or even have a physical response to the drug that's negative. So you often sometimes hear people say, I drank alcohol and I vomited the first time. So think about that. Right then, that person had a negative effect, and they're never going to go back to it. People could be peer pressured into it. There can be a homeschool work environment. So like, for example, people who work in bars or musicians who are constantly exposed to the drug can be in a work environment where they are more at risk. And sometimes people can be in a mental state where they're craving the drug to decrease the anxiety and stress. So I put a discussion question in there that really asks you to look at the physical and mental effects of a drug. But I'm going to tell you right now, if you look up the physical dependence on LSD, you're going to see that it's really low. Really low. People don't physically get addicted to LSD the first time, but they become physiologically not addicted, but they become they become addicted to it psychologically. Okay, so they become emotionally addicted to it, because you'll see that LSD inhibits and blocks and messes with the serotonin uptake. So serotonin makes you feel good, and it starts to rewire you emotionally. And some people actually can become mentally unstable. So look at that. Look at the potency of each of the drugs. Okay? So if you go back to the discussion questions, you can see that I'm going to be asking you to look at how someone has their first drug experience and how that can be either positive or negative, and how that can either build a dependency, either psychologically or physically, and how they build up tolerance. And then the other one for this week is really looking at neurotransmitters. I want you to look at the NIH videos, either choose cocaine, meth, or cannabis, and tell me how it affects the central nervous system. So make sure you watch the videos. And then I'm definitely going to put a quiz review for next week, but I want to tell you that in the quiz, I'm going to ask you to know the difference between physical addiction and psychological addiction, and I'm going to ask you what are the most physically addictive drugs that we are covering. So I'm going to definitely put a hint for the quizzes in the future. So go through the modules. Definitely watch the NIH videos. If you do that, you'll be good to go, because you'll understand the whole purpose of these 2 chapters. Read the chapters, do the 2 worksheets, and knock this out. Make sure you also do the chapter reviews too before the quizzes, because if you do the chapter reviews before the quizzes, you'll find that when we do the first quiz next week, you'll nail it. You'll do great. All right. If you have any questions, let me know. And I look forward to seeing your discussion post and your assignments.